This video is for September 22nd, September 23rd. We're looking at graphing tangent. And so in order to graph tangent, we're going to use sine and cosine because tangent is sine of x divided by cosine of x. And our x values, I'm going to put 0 here. We'll see y in a few minutes. And if we want around the unit circle, we want to make tangent easy. So for example, if we're at pi over 6 or the first radian measure above 0 at pi over 6, the tangent would be sine divided by cosine, or in other words, 1/2 divided by square root of 3 over 2. If we were to do that, square root of 3 would be in our denominator. We'd have to rationalize, not fun. But if we look at pi over 4, we have square root of 2 divided by square root of 2, because pi over 4 is right here. Something divided by itself is 1, so we'll use that. And we're actually going to count by pi over 2. So pi over 4, 2 pi over 4, which is just pi over 2. 3 pi over 4. We have pi and 5 pi over 4. And we'll say negative pi over 4 over here. All right. So I am going to do, let's say, negative pi over 4 and pi over 2. So we can say tangent of negative pi over 4. And we can find the coterminal with negative pi over 4. That would be 7 pi over 4. Will be coterminal with negative pi over 4. Sine at 7 pi over 4, the sine of 7 pi over 4 would be negative square root of 2 over 2. We divide that by cosine, which is square root of 2 over 2. Something divided by itself would be 1. We have a negative there, so this is negative 1. And so our ordered pair would be negative pi over 4, because that's what we input into our function, negative 1. Similar thing if we did tangent of pi over 2. At pi over 2, sine is 1. We're dividing by 0, which is undefined. So at pi over 2, we have an undefined line because we cannot divide by 0. And we could keep getting ordered pairs. I'm just going to go ahead and list those. Ordered pairs. If you have questions about them, please reach out. Pi 0 and 5 pi over 4 and 1. Those are our ordered pairs. Now on the x, if you pause it, I would encourage you to work these out. But if you want to pause it, work those out, make sure you get those, that might be good. Now on our x-axis, we're still going to go out 2 pi and negative 2 pi. Even though our scale here is different, we'll see why. Pi over 2. And let's just say this is 1, negative 1. We're going to have an undefined line at pi over 2. We're also going to have an undefined line at 3 pi over 2 because the sine of 3 pi over 2 is negative 1. Cosine of 3 pi over 2 is 0. Negative 1 divided by 0, undefined. So we're going to have an undefined line at 3 pi over 2 as well. And then over here. And the reason we have an undefined line at negative pi over 2 is because negative pi over 2 is coterminal with 3 pi over 2. So they're going to have the same value here, it's undefined. Similar thing with negative 3 pi over 2 and pi over 2, those are coterminal. So we have that there as well. Now what we're going to do is 0, 0 here. pi over 4. Pi over 4 isn't here, but it's halfway between 0 and pi over 2. So pi over 4 would be like here on our x-axis, and that's 1. Function's value there is 1. Negative pi over 4, negative 1. And then we have the same thing here, 3 pi over 4. If you have your unit circle out, you can see that 3 pi over 4 is between pi over 2 and pi. That function's value, tangent's function's value is there is a negative 1, pi 0. 5 pi over 4 is between pi and 3 pi over 2. And hopefully we kind of see a pattern already. Hopefully. And the way this function behaves, hopefully you remember from previous classes, this is called an asymptote because the function is undefined there, and it's also going to approach it but never cross. So our function ends up looking like this. It has a little bit of a bend to it, not much. And then it repeats, that's key. It repeats here, repeats here. Repeats again here. It repeats again here. So maybe that repeat word helps us determine one of our key features of the graph. And this is our function for tangent. All right. Has a funky look, but that's our graph. Let's see here. Let's see what we can cover. I think I can get all key features in on this video. Let's start with the domain, or sorry, the period. So our period here, the scale is at 2 pi. However, it's repeating pretty frequently, so we might need to rethink this. I said something about repeating. Now look here, it starts at 0 there. The function goes up. There's a break in the action, it's coming back here. It goes up from there. It reaches a 0 again there, and it does the same shape again. So we start at 0, we reach 0, the x-axis again here, and the function repeats the same behavior. And that function repeats every pi units. So our period here is pi. Our amplitude, hopefully we can remember from secant and cosecant. Cosecant and secant did not have an amplitude. And the reason they did not have an amplitude is because we didn't have a wave, because the amplitude measures the middle to the highest point, middle to the bottom. Well, here's the middle. Where's the highest point? We don't have really a highest point. We don't have a maximum. We don't have a minimum. It goes down forever, goes up forever. So our amplitude, write it down, put X through it. We don't have an amplitude. No amplitude for tangent. So period, amplitude. Let's talk about domain. If we're talking about the domain, we're talking about the x values of the function. And if we're looking on our x-axis, like with sine and cosine, it does go forever in both directions. It will use all values except certain ones. Hopefully we can see that it's undefined at these certain values. So we say that x can't be used there, or in other words, x cannot equal, because if we use these values, the function is undefined. Anywhere else it's useful. Plus or minus pi over 2, x cannot equal plus or minus 3 pi over 2, 5 pi over 2, and you get the point. Similar to secant and cosecant. Essentially what we're saying with this definition is that x can be anything we want except for these values. It cannot be these values. And so our range, we're talking about the y values. Well, let's take a look. If the function goes down forever, it keeps going down, it never touches this asymptote, it gets really, really close but never touches, it keeps going down forever. So we could start with a negative infinity if it goes down forever, it doesn't ever stop. Now, if we're down forever as we work our way up, it keeps going, and never stops. It never, ever stops. It goes up forever. It's going on forever in the positive direction. So that's going to be our range, negative infinity to infinity. It never stops going in the negative direction. It never stops going in the positive direction. And so our range is negative infinity to infinity. Pause it, make sense of it, rewind, do what you got to do. But these are our key features for our tangent function that will be, you will be held accountable for that on your assessments coming up. So make sure that you understand that. I will do one more video. Hopefully I'll post it soon. And that will look at how to graph tangent if we move it and shift it the ways we did with sine and cosine.